Another exercise that we did as part of class was to measure the height of a flagpole out in front of the college. Now, I strongly suggest that you go out and measure the height of something that you can't reach the top of using these methods without looking at what we're doing here, and then come back and look at how we measured the height of the flagpole. Okay, assuming you might have done that, hopefully. The class went out and set up an aluminum rod at a height of 49 inches, tied a string to that, and sighted to the top of the flagpole by stretching the string out. Turns out that the string stretched out so that a horizontal distance of 38¼ inches corresponded to a vertical rise of 19 inches. So that the two legs of this triangle with this angle here were 19 and 38¼ inches. Then the distance to the flagpole was measured. One of the students paces off distances for archery practice, has a very accurate pace, and determined that this distance was 63 feet, so that by constructing a triangle here, it was determined that the distance x, being in the same proportion to 63 feet as the 19 inches was to the 38¼ inches, gave us this proportionality. X over 63 is 19 over 38¼ solving by multiplying both sides by 63 and doing the arithmetic, we get x equals 31 feet. Then to get the height of the flagpole, of course, we add the 49 inches here and get something just a little over 35 feet for the height of the flagpole. Here's another way. 19 over 38.25 is 0.498. That's the ratio of the two legs of the right triangle, or the two legs of the triangle that form the right triangle. So we conclude that x is 0.498 of 63 feet, or about 31 feet. Just another way of looking at the proportionality. And then we, in either case, determine that the height of the flagpole is x, which is 31 feet, plus 49 inches, which is just over 4 feet, or within the precision of our round off, about 35 feet. Now, I'll say that I went out and measured the height of the flagpole by measuring the length of my shadow and the length of the flagpole's shadow, just pacing things off. And I estimated that the flagpole was between 34 and 37 feet, so that the 35-foot estimate was very consistent with mine. Not that mine is sacred in any way. I sometimes get these close, but sometimes I don't get them as close as I'd like to. Okay, now we have the definition. This ratio that we've been looking at between the two legs of the triangle, the leg opposite theta and the leg adjacent theta, has a name, and that ratio is what we call the tangent of theta. In this case, we would say the tangent of theta is our 19 over 38.25, which is our 0.498 ratio, which is written as 0.496 here, using various round-offs. You can use your calculator and validate the actual quotient here and the actual tangent and so forth. Now, if theta equals, or if tangent theta equals this, then theta is the inverse tangent of this. Inverse tangent of 0.496, you can calculate that on your calculator. You get something a little over 30 degrees, I think. If you're in radian mode, of course, you won't get something a little over 30 degrees, so be careful that you're in the correct mode when you do this on your calculator.